creating process flow diagrams. For this part of the course, we're going to use an example organization, an example plant that converts iron ore, which is mined in a number of mines and delivered to this plant. It is converted to direct reduced iron briquettes, for short DRI briquettes, which are then shipped to various steel mills so that the steel can be made of them. It's actually a very complex plant. It is, if you recall, product process matrix. It is an example of a continuous process, right? So at the right bottom corner, where you have a very high investment in equipment, in assets, in order to, as much as possible, reduce the unit cost of processing the product. And so the product is processed in a very high volume, extremely low variety, and the objective is to lower the cost as much as possible in order to be competitive. If you actually saw the plant, you would see it's extremely complex, and it's very difficult to actually try to understand it if you're not an engineer, an expert in the processes that are involved. But if you actually talked to engineers, you would have to come up with something that simplifies the process sufficiently. And what we're going to try and propose for this plant is to draw a process flow diagram, PFD for short. In a process flow diagram, we have activities which will be represented as rectangles, which are carried out by resources. They are the steps that add value to the product and that are required for completion of the product. And the problem with them is that these resources have a capacity or maximum number of flow units that can flow through the activity within a unit of time. So recall that capacity is just maximum flow rate that the process or one of the activities in the process can process per unit of time. We will also have arrows which indicate where the units are flowing. And we will also have buffers indicated by these triangles. They don't have capacity, right? They don't have capacity. They don't have maximum flow rate they can process. However, there might be a limited number of flow units that can be put in this buffer at any moment of time. And there might also be sometimes in the process flow diagrams decision points if some units follow different paths through the process. So if we try to draw the process flow diagram for circular plant, we could come up with this kind of process, and it's actually quite simple. It's very linear, right? It starts with a buffer which contains the iron ores that were delivered from the mines, and then it goes through 7 steps, including preheater, lock hoppers, first reactor, second reactor, flash heater, discharge, and briquetting. And then there is the buffer with finished goods. We could also overlay this process over the engineering drawing to have a better idea where different parts or activities are carried out on which resources. So things to remember when we plot a process flow diagram: we need to determine process boundaries and perspective. We need to take the viewpoint of a unit of flow. In this case, right, this briquette or iron ore that becomes a briquette later on. We need to emphasize essentials, right? There will be a lot of equipment that actually is not important to reflect in the process flow diagram. There's probably some major pieces of equipment that are key to understanding the process, and a lot of details, a lot of maybe types of workers who we don't need to actually represent in the process flow diagram. Right? It's important to concentrate on the activities, on the process steps that add value, and then see if there are any important buffers or decision points and where the flow of units is moving what order. And one more detail is if you have a step that is both an activity and a buffer, usually we should consider it as an activity because activity adds value and it needs to be reflected as an activity in that case.